Hi everyone, today we're going to be discussing issues with judgment and decision making. First, let's begin with some definitions. By decision making, I mean generating, evaluating, and selecting among a set of relevant choices with the intention of producing a favorable outcome. For instance, if you haven't decided what you want to do with your life when you graduate from FSU, you may be considering several options: going to graduate school, getting a job to pay off your college debt, or traveling. That is, you'll need to make a decision. It may not be clear which is the best choice or if there are other options you haven't considered, but this highlights some of the issues with decision making. And then by judgment, I mean an opinion about what is or what will be the status of some aspect of the world. It often involves determining the probability or likelihood of something. For example, we may be asked to judge the probability of being accepted to graduate school, or the probability that an individual has some characteristic, or we may estimate the probability of some event occurring, like it raining tomorrow. Today, we're going to look at three categories of errors and several examples of errors in each category. The idea is these are the types of things that may lead people to make a bad probability judgment or choose the wrong option when making a decision. The first is using a heuristic, which is a rule of thumb or shortcut when making a decision or a probability judgment. So when people make decisions, they often don't take all of the available information into account. Instead, they use shortcuts or educated guesses to arrive at a solution faster. For instance, if I asked you to estimate what percent of FSU students take summer online courses, how might you go about answering this question? Well, you could send out a survey to every FSU student asking whether they took an online course during the summer, or you can think about what percent of your friends are taking an online summer course and assume the same is true for the university as a whole. I think most people would intuitively choose an option like B, that is to apply a rule of thumb or a shortcut. The percent of students at FSU who take online summer classes is similar to the percent of my friends at FSU who are taking online summer classes. However, using heuristics leads to certain errors with judgment and decision making. The first type of heuristic I'll mention is the representativeness heuristic, which is about judging the probability of something being true based on how similar it is to something else. So, the representativeness heuristic is often used when making judgments about the probability of something being true, such as a person being guilty, or a person having a disease, or a person belonging to that category. And with the representativeness heuristic, we're basing our probability judgment based on how similar or representative that person is of that category. The logic goes something like this. A guilty person behaves in a certain way. Stephen acted that way, and so Stephen is probably guilty. When you estimated the percent of students at FSU who take online courses using the information about your friends, you applied the heuristic that your friends are representative of the FSU student body. So you used the representativeness heuristic. The issue is that the representativeness heuristic doesn't take many factors into account, which can lead people to make bad judgments. So again, these are factors that are often not taken into account when people use the representativeness heuristic, or another way of looking at them, they are reasons that using the representativeness heuristic can lead people to make incorrect judgments. Let's discuss the first factor by looking at an example. A certain town is served by two hospitals. In the larger hospital, about 45 babies are born each day, and in the smaller hospital, about 15 babies are born each day. As you know, about 50% of all babies are boys. However, the exact percentage varies from day to day. Sometimes it may be higher than 50%, sometimes lower. Here's the question. For a period of 1 year, each hospital recorded the number of days on which more than 60% of the babies born were boys. Which hospital do you think recorded more such days? The larger hospital, the smaller hospital, or that it was about the same? So take a second here and decide which of these options you think it is. Now in studies, about 22% of people say it's the larger hospital, about 22% say it's the smaller hospital, and then 56% say that there's no difference. However, the correct answer is the smaller hospital. If you said the larger hospital or that they are about the same, you fell victim to the small sample fallacy, which is believing that small samples are as representative of a population as large samples, which they are not. The key point is that small samples are less representative than large samples, but people often aren't aware of this. Consider this example. If I flip a coin 4 times and I get 1 head and 3 tails, would you be surprised? Well, no, probably not. And so in this example, getting 75% tails isn't that surprising when the sample size is small, with only 4 flips. But if I flip a coin 100 times and I get 75 tails, would you be surprised then? Well, probably yes, you would. Why the different reaction to 75% tails when the number of flips is large versus small? Well, it's because at such a large sample size, you would be surprised that the result isn't closer to 50% heads and 50% tails. In other words, having a non-representative outcome of 75% tails is strange in a large sample size of 100 flips, but it's not strange in a small sample size of 4 flips. To go back to our example then, although on average 50% of babies born on a particular day are going to be boys, we'd expect to get more non-representative samples of 60% boys when the number of births is small, from the smaller hospital, than when we have more births from the larger hospital, when the sample size is larger. The next factor that's often not taken into account when using the representativeness heuristic is the base rate fallacy, which is failing to take the base rate, how common something is in the population, into account when making probability judgments. To illustrate the base rate fallacy, I'm going to show you a description of a person who we know is a psychologist. First, let's think of some different areas of psychology. So there's developmental psychology, cognitive psychology, counseling psychology, forensic psychology, etc. So lots of different areas of psychology. Okay, here's a description of a psychologist. Bill has always liked solving mysteries and figuring out why people do the things they do. He is very exacting in measurement procedures he uses and very careful in observing in his observations of people. He enjoys mathematics, statistics, and doing puzzles by himself. So here's the question. Is it more likely that Bill is an experimental psychologist, which is a psychologist who is interested in research and statistics, or a clinical psychologist, which is more likely? Now, Bill sounds like an experimental psychologist, so you might assume that's more likely. However, there are actually about 5 times as many clinical psychologists as there are experimental psychologists. In other words, given the large base rate of clinical psychologists compared to experimental psychologists, it's actually much more likely that Bill is a clinical psychologist. But again, why do a lot of people say that Bill is an experimental psychologist? It's because he sounds like one, because he is representative of one. So, those people who said that Bill is more likely to be an experimental psychologist than a clinical psychologist because he sounds like one were using the representativeness heuristic. And they ultimately made a reasoning error. They made the wrong decision, and that's because they fell victim to the base rate fallacy. They didn't take the base rate into account, that in the population, clinical psychologists are much more common than experimental psychologists. The next heuristic is the availability heuristic, which is estimating the frequency of an event based on how easy it is to recall examples of that event. So we often use how easily we can bring examples of some event to mind to help us estimate how frequent it is. For example, which of these is more dangerous? Riding rides at amusement parks or riding your bike on the road? You might say amusement parks because you could remember lots of examples on the news of people getting injured on amusement park rides. But you're actually much more likely to get injured by riding your bike on the road. The key point is that in this example, we use the availability heuristic. We estimated which event was more common, injuries at amusement park rides or bike rides, based on how many examples of each we were able to remember. Next, we're going to do the same thing we did with the representativeness heuristic and talk about some factors that aren't taken into account when people use the availability heuristic. Again, these are the reasons why relying on the availability heuristic can lead to people making bad judgments. The first factor is the media paradox, which says that the media focuses on reporting rare events, so basing frequency judgments on rare events on the rate they're reported on the media leads to overestimations. You may have heard the saying, "Dog bites man won't make the news, but man bites dog will." The point that this saying is getting at is that an event has to be somewhat rare to make the news. Well, remember, the availability heuristic is about judging the frequency of an event based on how many examples of the event we can think of. So, if we rely on our memory for estimating the frequency of events based on information from media reports, we'd come to overestimate the frequency of many types of rare events, because those are the ones that are more likely to make the news. A good example of this is estimating the frequency of different types of deaths. In one study, 58% of participants said that deaths by tornado are more common than deaths by asthma, when in actuality about 900 times as many people die from asthma attacks as from tornadoes. Of course, tornado disasters often make the news, while deaths from asthma don't. So people think tornado deaths are more common because they base these judgments on how often they're reported on the media when they shouldn't. And then the second factor that's not often taken into account is the vividness problem, which says because memory is best for vivid events, the presence of one or a small number of contradictory cases can have an undue effect on frequency estimations. This is why anecdotal evidence is so powerful, because it creates a vivid exception in our memory. When we go to make decisions then, this exception easily comes to mind, and our decision making is unduly influenced by it, versus relying on better types of evidence. A good example is that after the September 11th attacks, many people chose to drive instead of fly, as there was this recent vivid example of the dangers of flying. In reality, flying is much safer than driving, and so because people chose to drive instead of fly, about 700 people died in the final months of 2001 that wouldn't if they had chose to fly instead. But this demonstrates the vividness problem. This one event about the dangers of flying stood out in people's memory, and it led to people making bad judgments and believing that driving was safer than flying. The last heuristic I'll mention is the anchoring and adjustment heuristic, which says that people often base their answers on anchors or salient values, but fail to adjust sufficiently. For example, in a study involving a mock court case, judges with an average of 15 years experience were told about a hypothetical crime. They were then given two sentence recommendations by a mock student prosecutor, either 12 months or 36 months. Those judges who heard the 12-month recommendation gave an average sentence of 28 months, while those judges who heard the 36-month recommendation gave an average sentence of 32 months. The idea is both sets of judges were given the same information about the crime, so theoretically, their sentences should have been the same. However, that was not the case, and instead, their sentences were influenced by the recommendation from the mock prosecutor, illustrating the anchoring and adjustment effect. Specifically, those judges that were given the smaller recommendation issued a shorter sentence, while those judges who were given a longer recommendation issued a longer sentence. The next type of error in judgment and decision-making is biases or distortions in thinking. Sometimes it can be knowledge that we have that distorts our judgments, or sometimes in the process of trying to make decisions, we do things that distort our judgments. One example of a type of bias that we've talked a lot about this semester is confirmation bias, the tendency to notice, accept, and remember evidence that supports one's beliefs, and to ignore, discount, or forget evidence that contradicts them. So I won't really go into confirmation bias again, but just to understand that this is a good example of a bias people show that distorts their decision making, because it causes them to only consider some of the evidence. The next bias I'll mention is the halo effect, where people who are given high ratings on one trait, such as beauty, are evaluated as being higher in other unrelated traits like intelligence. In other words, our positive ratings of a person on one dimension essentially spill over to other unrelated dimensions, making our ratings on those dimensions of that person more positive. For example, in one study, participants were given either a well-written or a poorly written essay to grade, and were shown a made-up picture of the author who was either attractive, average-looking, or not attractive. For both kinds of essays, the attractive person was given a higher grade than the average or unattractive person, implying that the grader felt that the attractive person was more intelligent or more deserving of a higher grade than the average-looking person or the unattractive person. The difference was larger for the poorly written essay, where the author was awarded 5.2 out of 9 if they were attractive, versus 2.7 out of 9 if the author was unattractive. The next bias is the framing effect, where the way a question is worded can affect a person's response, even when the outcome or issue is the same. So consider this scenario. Imagine the U.S. is preparing for the outbreak of an unusual disease, which is expected to kill 600 people. Two alternative programs to combat the disease have been proposed. The estimated outcomes of these programs are as follows. If Program A is adopted, 200 people will be saved. If Program B is adopted, there's a 1/3 chance that 600 people will be saved and a 2/3 chance that 0 people will be saved. So, which of these programs do you prefer, A or B? In the actual study, more people preferred Program A to Program B. Now consider this scenario. Essentially, the event is the same, but now we have two different programs to consider. If Program C is adopted, 400 people will die, whereas if Program D is adopted, there's a 1/3 chance that 0 people will die and a 2/3 chance that 600 people will die. Now, which of these programs do you prefer? Okay. In the actual study, more people preferred Program D to Program C. So, why is this interesting? Well, the reason this is interesting is that programs A and C are the same, and programs B and D are the same. Logically, you would expect the same percent of people to choose A and C, and the same percent of people to choose B and D. However, that's not the case. Instead, this example demonstrates the framing effect, that our decisions are biased by the language used or how the problem is framed. Specifically, saving 200 people out of 600 sounds great, but accepting the death of 400 out of 600 people sounds horrible, even though both are the same. This is why in debates like over abortion, you have one side identifying themselves as pro-life, and the other side identifying themselves as pro-choice, as opposed to anti-choice versus anti-life. The issue doesn't change, the question is still whether women should have the right to have an abortion, but by using the labels pro-life and pro-choice, both sides are framing the argument in a manner that makes their side seem better. The next bias is the illusory optimism effect, which is the tendency to overestimate the likelihood that something good will happen to you and to underestimate bad events. So if you ask someone who, isn't in this class and isn't a good critical thinker, compared to others, how likely is it that you'll get sick in the next month? More likely, less likely, or equally likely? Well, I bet most people you ask would say less likely, but this just doesn't make sense statistically speaking. So this fact might explain why people are willing to smoke cigarettes despite knowing about the increased risk of lung cancer from smoking. They might be overly optimistic and decide, well, it won't happen to me, when it's just as likely to happen to you versus anyone else. The last category of errors in judgment and decision-making are metacognitive errors, which refers to a discrepancy between the actual accuracy or quality of a person's judgment and his or her belief in its accuracy. Metacognition refers to our ability to make decisions about our own cognitive ability, how confident we are that we know the answer to a problem, or how accurately we can make a good judgment. Overall, people are pretty bad at making metacognitive judgments, and here are some reasons why. The first is hindsight bias, which says that after an event has occurred, the likelihood of that event occurring is judged to be greater than pre-event judgments. Sometimes it's called the knew it all along effect. The idea is once you know something has happened, it seems more certain to you that it would have happened. Think about when a sports team wins a game that they weren't expected to, or a politician wins an election he or she wasn't expected to win. Commentators come up with a bunch of reasons why it's not surprising that they won, even though the commentators didn't predict that outcome ahead of time. In one study, participants answered a set of questions and rated the probability that they got the answer correct. 1 hour later, they were told which questions they got right and were asked to remember their original confidence ratings. When participants were told they got the answer correct, 72% of the time their confidence ratings they gave on the second rating were higher than their initial confidence ratings they gave on the first rating. That is, knowing that they got the answer right made them more confident that they knew the answer all along. The next metacognitive error is overconfidence, that people overestimate their ability to make accurate judgments and decisions. So in general, people think they are more accurate at making decisions than they actually are. In class, I show students these 10 questions, and I ask them to construct 90% confidence intervals around each question so that they are 90% confident that the actual answer to the question falls in between those two numbers. Let's just do this one as an example. What I want you to do is to come up with two numbers so that you are 90% sure that there are between that many countries and the other number of countries in the United Nations. So again, you probably don't know the exact number of countries in the United Nations, but you should come up with two numbers so that you're 90% confident that the answer is in between the smaller and the larger number. Okay, so do that now. The actual answer to this question is 193. So, if 193 was not in between your two numbers, you were overconfident. You should have made the interval between your numbers larger. And in class, yeah, students are just too overconfident. For them to be accurate in their metacognition, 9 out of their 10 answers to these 10 questions here should be in the ranges they create. But it's usually only 5 or 6 of the ranges that contain the actual correct answers. Next, we have illusions of control, where people believe they have more control over the outcome of events, even random events, than they actually do. So the line between things like athletic competitions, where skill does matter and individuals can affect the outcome, and the lottery, where skill has no bearing and the outcome is random, the line between these events becomes blurred. For instance, choice is one factor that can produce illusions of control. Many lotteries will let you pick the numbers because people think it increases their odds of winning, so they're more likely to play. Here is a quote, which is again completely wrong, by someone who won the lottery. Don't play quick picks. The computer picks out the numbers. Quick picks are the worst thing you can do. You are playing the worst odds. And again, this is an example of an illusion of control metacognitive error. They're saying that because the computer picks the number for you, that decreases your chances of winning, when again the outcome is random, and it doesn't matter if you or the computer pick the number. You have an equal chance of winning. The final metacognitive error I'll mention is the certainty effect, where the complete elimination of risk is overvalued compared to an otherwise equal-sized reduction in risk. This example is a little morbid, but please bear with me on it. Let's consider two scenarios. Here's the first one. Suppose you are forced to play a standard round of Russian roulette. You will spin the cylinder of a gun that contains one bullet, aim the gun at your head, and pull the trigger once. How much money would you pay to remove the one bullet from the cylinder? Now, I'm not sure what a correct answer would be, but try to come up with a number that you'd be willing to pay to do this. Okay, now consider this second scenario. Same as before, but now imagine that there are 4 bullets in the gun's cylinder instead of only 1. Now, how much money would you pay to remove one of the 4 bullets at random? Again, I don't know how you can answer this question, what's the right amount of money, but try to come up with a number. Okay, the reason why these scenarios are interesting is that removing one bullet in each scenario decreases your risk of dying by the same amount, about 17%, but people pay more to do so in scenario 1. That is, they overvalue the complete elimination of risk. So again, people will pay more to remove one bullet in scenario A, where their risk of dying goes down by 1/6, from 1 out of 6 to 0 out of 6, than they would in scenario B, where the risk of dying goes down by 1/6 again, from 4/6 to 3/6. So the point is that the complete elimination of risk in scenario 1 is overvalued compared to an otherwise equal size reduction in risk in scenario 2. To summarize our discussion in today's class, and basically this entire semester, good critical thinking involves an efficiency-price trade-off. That is, these heuristics, biases, and metacognitive errors simplify our decision-making at the price of accuracy and cause errors in critical thinking. That is, people often ask me, why do people make these types of errors in critical thinking that we've been discussing this semester? My answer is that they either don't care, they don't know what they're doing is wrong, or that they don't take the time to think critically. To apply this answer to today's PowerPoint, these heuristics and biases are often true, which is why people use them. And they certainly save time and simplify our thinking. But sometimes using these heuristics and not realizing our biases leads to poor decisions and errors in critical thinking. To avoid these and other thinking errors, then, recognize that you may need to take more time when making important judgments and decisions. That is, your initial judgment will probably be affected by these biases and errors, but you can then examine your thinking to see whether you've made such an error. And you can then apply what you've learned about critical thinking in this course to make better decisions. Well, that's all for me this semester. I hope you all enjoy the course and that you have a great rest of the summer.